Hey everybody. Okay, so today's lesson's going to be a little bit different than I've been doing it. I tried it already on the other 280 class and it seemed to work a little better. So what I'm going to do is I'm going to break the video up into at least two videos. That seems like it's a little bit easier to upload it to YouTube. It doesn't take quite as long, so that hopefully my lesson will not be late getting loaded up to Canvas. So the first part here, will be a few minutes or whatever, and then I will let you know when I'm starting a new video. Okay, so here's my first question, and it's on the board there. And this you do not have to turn in to me as part of your homework. This is just for a starting point for us to talk about. But I have these two expressions, those two different expressions, and the question I have for you is there a difference between these two expressions? If so, what is the difference? And if not, why isn't there a difference? Okay, so again, just take a moment to hit pause and then either write down, because you don't actually have to turn it in, but you could write down what you want to say, or at least just seriously be thinking about what it is you'd like to say. So go ahead and hit pause and do that for a moment. Okay, so I'm sure you had a chance to at least think about what your answer might be. And then if I pulled it down a little bit, you might get a bit of a hint, I think, if those of you that can remember what you did back in the day about volume. And one of these expressions has to do with volume and the other one does not. So I'm hoping that you said, yes, there is a difference between them, because yes, there is a difference between them. So this equation, okay, has to do with volume. And this equation, you may not have known what this one was, but this one should have looked familiar to you because this has to do with area. Okay, so the area of what shape is this one? Well, I'm pretty sure we all know that the area of this one is length times width. Or excuse me, is a rectangle because it's length times width or base times height. This one is a little bit different. That capital B makes a difference. It's not arbitrary that I wrote a capital B here and a lowercase b here, okay? So here's what this means. Whenever you have a capital B in your equation like that, this capital B means the area of the base, okay? So for your 3D shape, whatever base shape it is, you need to use that equation and then multiply it by how tall or how deep that 3D shape is. So if we're talking a rectangular prism, okay, so a rectangular prism, volume is equal to the area of the base times the height. So for a rectangular prism, that capital B could be length times width, and then times the height. Okay? So let's take a look at another one. So then you just plug in your length and your width, multiply it by the height, and that gives you the volume. For a triangular prism, the equation is still volume equals capital BH, right? So the area of the base times the height, except now this base is no longer length times width, it's 1/2. Whoops, let me get a little bit bigger there. It's 1/2 the length times the width times the height. Or you could say 1/2 of the base times the height of the base and then times the height or whatever. But basically this is the third dimension of the 3D shape basically. Okay, so half of the length times the width. If it happens to be let's do this color, cylinder, okay, the equation is still volume equals area of the base times the height. The difference this time is my base is pi r squared. Let me write that a little bigger. Is pi r squared times the height. So the formula for volume is always the same. It's always the area of whatever your base is times the height. And then depending on what the base is, whether it be a rectangle or a triangle or cylinder or an octagon or whatever it happens to be, you need to find the area of that base using the formulas and then multiply it by the height. Okay? So that's the volume of equation for 3D solids. Okay, I'm going to press pause and set up another little quick activity. Okay, so the next thing we're going to take a look at here is a manipulative that, had we been live in class, this would have been our main manipulative we would have used. But since we weren't, I'm just going to bring it out right now, take a look at it, and see how it might help us understand this a little bit better. So here we have a bunch of three-dimensional shapes. And so here is a cube or a rectangular prism. Here's another rectangular prism, definitely not a cube. Here's a triangular prism, okay? And then here is a hexagonal prism. So these are all of our prisms, and then this one's a cylinder, of course. Not kind of like a prism, but not exactly a prism. And then these ones over here kind of go together because those are my pyramids and cones. Okay, so the cones are kind of related to the circle, and the pyramids are related to whatever base shape they have. So this being a triangular, a triangular prism, or cone, pyramid, because the base is a triangle. All right. This being a square prism, or a rectangular prism. Pyramid, a square pyramid or rectangular pyramid, because the base is a square, and so the that names it, right? Remember, we name it by the base, and that's how we stand it up. Okay, now you may have already noticed that these cool about these is the nets unfold, and this is what we would have done in class. Is we would have been able to use these nets to see how the different shapes are made. We also can do that height of a pyramid versus the slant height, so the vertical height or the altitude, and the slant height is good with these. So these are the different nets that fit right inside here. And remember that the net represents the surface area. Okay, surface area was last week. What we're doing this week is we're doing volume. Okay, so we're doing the volume of these shapes. So if I look at this one and I pull it out. Pull the net out of here. Okay, so this would be the surface area. Okay, that's the surface area of it. And then everything that fits inside of this shape would be my volume. And that's what we're figuring out today, is how much space would fit inside of here. So surface area is the stuff that goes around the outside. That's like this. And then the volume is what fits on the inside. Now, if I'm going to try and find the volume of this, basically what I'm going to do, as we just saw from our last bit of video notes, is I find the area of this base, and I see how many times that base fits inside of this prism. So basically stacking that up. If it's a triangular prism, okay, so I'm going to find the area of this base here that I have, and then how many of those would stack up in here, and that would give me the total volume inside of this prism. That's basically what we're doing. So in order to do that, basically what we're going to do is we're going to find the area of the base and then multiply it by how tall that is. That would give me the volume of this prism. And all prisms are done the same way. Doesn't matter what the shape is. So this one, area of the base, right? So there's my base. Find the area of that base, multiply it by how tall that is. So if I'm standing it up like this, that's the height of it. And so however the distance between there and there, that height there, times the area of that base gives me the volume of this shape. Same for cylinders. Find the area of this base right here, which is a circle, so that's pi r squared, and then how tall this is, or the height of it. Okay, that's what we do for all prisms and cylinders, is we find the area of the base, and then you multiply it by the height. It's actually quite simple. Okay, so I'm going to pause here just for a second, and then go back to some other notes. Okay, So now we're going to take a look at the calculation on how you might do this if you're given some three-dimensional shapes. So the first one here is a triangular prism. So I'm going to find the volume of this triangular prism. And so the equation that I'm going to use always for volume is V equals the area of the base times the height. And so all I need to do for this particular problem is figure out what my equation I use for the area of my base. And since this is a triangle, the area of a triangle is 1/2 length times width. So I'm going to use that for my area of my base. That's 1/2 LW. And then I still have the height of the triangular prism. So if I think about a triangular prism here, that's standing it up on its base. And so this part right here is the height of it. So I'm finding the area of this base by doing 1/2 base times height. And then I multiply it by that distance there. Okay, so now I'm ready to plug into my equation, right? So I see that for my triangle here, I have the 6 is pointing to the middle. So that means it's the height of my triangle. And the 10 is my base. So I'm going to have 1/2 of 6 times 10. And then the height of the prism is 12. And so that's 12 like that. All right. So now I am ready to do my problem. So what I see here is I'm going to go 2 goes into 6 3 times. I'm always going to simplify first. So now 3 times 10 is 30 times 12 is equal to 360 units cubed is your unit. So it's not squared like area, it's units cubed. So the volume of this, if the height were of the triangle were 6 and the base were 10 and the height or the depth of this prism was 12, then the volume of that would be 360 units cubed. If it's inches cubed, whatever. Okay? Literally that's it for volume. Okay? So now we're taking a look at this one. So now this one that we have here is a circle, right? So I'm going to do the same thing though. It doesn't change. The volume formula is volume equals the area of the base times the height. That's it. So all I need to do this time is figure out what is my base. So for this one, the base is a circle. And so the area of a circle is pi r squared. So instead of using 1/2 base times height or length times width like I did last time, I'm going to use pi r squared and then multiply it by the height. Okay, so every time I multiply it by how far apart my two bases are. That's what I'm doing. That's the height of the prism, or in this case, a cylinder. Okay, so then I got to plug in and I say that I get, this is equal to about 3 times, and then my r, if my diameter is 30, then my radius is 15 squared, and then times 12. Again, why do I keep using 12 for the height of these things? Okay, so 15 squared is 225, and then times 3 is 675, I believe, and then times 12. I'm not sure what that is. 675 times 12. I'll have to do that over here. Did I do that one right? Let me see here. I think it's 810. So 810 units square, or excuse me, 8,100 units squared or cubed. Okay. And you might want to check my multiplication over there. I did it pretty fast on the side. All right. But it doesn't matter. If you get to this point right here, I'm fine. Right. So this is basically, this is the part that I'm looking for sure you know how to do. Okay. Now look at that bottom one there. So the hexagon. So for the hexagon, I I had to give you guys a little bit different dimensions here because it was hard to write on there. So I went ahead and went A, B, C, D, E, F, and G is over there. And so the distance from A to B is 5. The difference, and it's equilateral, so that means they're all 5. That makes it easy. The difference from the distance from A to D is 11. And the distance from B to F, so from those 2 points, is 8. All right, those are the dimensions that we need. And then A to G is 20. All right, so volume is equal to area of the base times the height, okay? So for this one, what I might do is, so what I see here is I see that if I cut it like this, I have 2 trapezoids, right? I got a trapezoid here and a trapezoid there. So I could use the trapezoid equation and then just double it once I get that. So the area of my base is equal to 1/2 the height times, am I on the board over there? Yes, I am. Okay. B1 plus B2. Okay. So the area of the base is equal to 1/2 of the height times B1 plus B2. And then that would give me this half of it, and then I just have the other one. So I would have double that, okay? So really what I could do is just forget about that 1/2, because I'm gonna take half of it here and half of it there, so it'd give me the whole hexagon. So it's just half of the base 1 times, or plus base 2 times the height. Okay, so that's this formula right there then. Let me plug that one in. Volume is equal to 1/2 the height times B1 plus B2, and then times 2, because I have 2 of those, and then times the height of my prism. And then times 20, okay? Okay, so what I was saying there is that this 2 and this 1/2, those are gonna simplify out. So those become 1s. So really all I'm gonna have to do is this work right here. So the height of my prism, that would be the BF. So that's 8 times, and then B1 is right here. That is from A to B is that distance, which is also the same as this one because it's an equilateral. So AB is equal to 5. And then the B2 is from A to D, so that's equal to 11, and then times 20. So if you multiply all that together, you'll get the volume of this prism, all right? So I'm gonna go ahead and multiply, and so I get 40 times 220, right? So then that's going to be 88 and then 2 zeros. So 8,800 units cubed, I believe. And again, check my multiplication there. It's possible that I might be off by a little bit, but I think that's right. So that's 40, 22, 220. All right, check that. Okay, so basically though, if we go back to this, what I had to do is find the area of the space. I don't care if you can catch that if I have half of it here and then I double it, I'm gonna get the whole thing. You could just find this half right here and then just double it and you'll still get to the same base that I got. So it doesn't matter to me how you do it. Okay, but basically for all prisms, you're gonna do the area of the base times the height. Area of the base times the height. Find the area of your base and then multiply by the height. That's for all prisms, cylinders, all those shapes. It's pretty simple. Okay, just gotta find the area of that base and then multiply by the height. Okay, so that's volume of prisms. And I'm gonna go ahead and stop the video now, and then I will start another video in just a moment.